Hello everyone, welcome to today's video. I'd like us to look at transportation model, which is one of resource allocation techniques that we have, and the transportation model we are going to look at the least cost method. Transportation modeling finds the least cost means of transporting goods from several origins to several destinations. To use the transportation model, we need to know three things, which are the origin and the capacity of, of, of supplying per period at each, destination points and demand points each, the cost of transporting one unit from each origin to each destinations. And we are going to look at a case here, and a case of a corn miller who was three farms where he mills in three different locations, and he sources corn and processed corn from three different farms. And the sources are S1, S2, and S3. The capacity for each source 1 is 150 tons, source 2 is 175 tons, and source 3 is 275 tons. On the destination, which are the factories where the corn is supposed to be transported, destination 1 is requires for us a demand of 200 tons. Destination 2 has a demand of 100 tons. Destination 3 has uh, a demand of 300 tons. The cost of transporting from source 1 to destination 1 is 6,000 Kenyan shillings per unit. The cost of transporting from destination 2 from from source 1 to destination 2 is 8,000 Kenyan shillings, and the cost from source 1 to destination 3 is 10,000 Kenyan shillings, and so forth for each source and each destination. So we need to understand the steps in solving this transportation problem. First, we need to ensure that the problem is balanced, such that the total supply is equal to the total demand. And then set up the initial transportation table, which includes supply for every source and demand for every destination. Uh, and step 3 is obtain the initial solution using either the northwest corner rule method, least cost cell method, or the Vogel's approximation method. In our case, we are going to use a least cost method, and this is how we do the table. We have uh, our destinations and our sources. Uh, the cost of transporting from each source to each destination, where we 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 indicate it at the right corner of each box, and we have the supplies from source 1, source 2, and source 3, and we have uh, the demands from for destination 1, destination 2, and destination 3. As we said in the requirements, that the demand and the supply must balance. If they don't balance, then we need to have a dummy column, but in our case we don't need a dummy column. So uh, our 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 demand and supply are balanced. So to solve this problem, or to get the least cost, we need to proceed from every column and check the least cost of transport. Le- In our first column, that the least cost is 4. So, and the demand for destination 1 is 200 tons, and the supply uh, is uh, is 275 tons. So we can transport 200 tons from uh, source 1 to destination, so from source 3 to destination uh, 1 at 4,000 shillings per unit, which is will transport 200, and have 0 here, and we'll subtract 200 here, we'll have 75 tons remaining. Once we do that, we can cancel this column completely, because we won't, it's already sorted, the demand is already sorted. We come to this other column. The least cost is 5, so we can and we have a supply of 75, so we can supply 75 to uh, destination 2, 75. So that will make this a 0, and we'll have 25 unmet demand for destination 2. If we can also cross out this uh, row, so that we can only have these ones, and now we have 8, 10, and 11 for the cost of transportation. So the least cost here is 8, and and the demand for this is 25. So we can supply 25 units here at 8, and have a 0 there, and here we'll have unsupplied 125 tons. Okay, so here we have a demand of 300, and the cost for transportation is 10 until 11. So we'll supply 125 tons to at the cost of 10 to destination 3, and we'll have still a demand of 175, which is unmet, and that will be supplied at 11, and finally we will have supplied every destination with the demanded requirement for milling. So to get the least cost, now we multiply the amount of tons times the cost. Now, remembering that our cost was in 1,000 shillings, so we'll multiply the 200 by 4,000, 25 by 8,000, 75 by 5,000, 125 by 10,000, and 175 by 11,000. Then sum it up and get 4,550,000, and that is our lease cost. And we have to note that this is not the optimal solution. This is just a feasible solution. It is not necessarily the optimal solution. That's why there's need for optimality testing. And in our next video, we look at how we test optimality. Uh, Please like, share with friends and colleagues, and subscribe as we watch out for the next video. Thank you.